All right, our final one is going to be number 40. It's a classic, so it shouldn't take too long. All you got to remember is your trigonometry, and I know that by this time you are expert and you remember all of the unit circle. Yes? I hope. Okay. So anyway, we've got this plane flying toward this person, at least horizontally, not down that hypotenuse. That would be a whole different problem, and we're not doing that. So it's headed horizontally. It's flying at a height of 5 miles above the ground. We've got this observer over here. We're going to set up our gist. It's asking how the angle of elevation, this theta, is changing with time. It's a 3-part question, but really if we can just set up the gist, all we got to do is change the numbers around. So here we go. All right, we are given that the height is 5 miles, and because we're dealing with a triangle kind of in standard position, I'm going to think of this as x and this as y. That way it ties into our unit circle stuff too. So our y is 5 miles. We don't know what our x is. We don't know how far away that is. But we do know that the plane is moving at 600 miles per hour. That looks like a change in distance over change in time. So that distance isn't our y distance. This plane is staying at 5 miles above the ground. But what is changing is the horizontal distance between the plane and the person. Since that distance is getting smaller, we have a change that's negative. So our change in the horizontal distance is decreasing by 600 miles per hour. Since I said we're going to call this x and this y, this rate is dx over dt. That is the hardest part of this problem. So if you can understand that, the rest of it's going to be simple. All right, we are looking for d theta dt at the instant when theta is 30 degrees. And then all we have to do now is figure out which formula we need. Well, we've got a theta, we've got an opposite, and an adjacent. That sounds like tangent to me. So I'm going to look for tangent of theta is equal to 5 over x. There is everything that we need. Because now if I want to find d theta over dt, I'm just going to take the derivative with respect to time of tangent of theta and the derivative with respect to time of 5 over x, which I suppose we should probably rewrite, right? 5 over x is the same thing as 5x to the negative 1. Right? So then the derivative with respect to time of tangent of theta is going to be secant squared theta times how the angle is changing with respect to time. This is going to be negative 5x to the negative 2, derivative of the outside function, times the derivative of the inside function, which is dx over dt. Now, we know that theta is 30 degrees here, so make sure that your calculator's in degree mode if you're going to use it that way, or you could always switch to radians if you want. We can plug in theta. We're solving for d theta dt. We have a dx over dt, but do we have an x? We don't. So what we have to do for that one is to plug into here and find tangent of 30 degrees is equal to 5 over x, and solve for x so that we can plug it in there. And that's how you can do parts A, B, and C. All right, this is our last one. I hope you enjoy your snow day. My son just left to go play outside in the snow with his friends, and I'm about to go shovel. Toodles.